Okay, I will make your name today after. Okay, morning, Mohan, I don't know.
Also has to send the final study for one day.
Morning session. After that only you can do.
Then only I have to call.
Okay, I will call him, then after that you can do. Okay, tomorrow I will fix it here through WhatsApp. I will fix it, then I will send it. Okay.
By which time I have to post, sir?
Today morning, actually, Ramana madam only posted today morning. Sir, under invigilation, he said that we have posted and we have to stop now. Okay. To the peak, 4:30. 4:30, we can post to the 4:30. Suppose if he completed before that also, we can. Madam.
ఓకే వస్తలే వస్తలేండి మాస్టర్.
Madam, Devi Garani, madam.
Yes, sir.
Okay, shall we go to sir?
Yeah, I'm available.
Okay. So I'll start now, sir. Very good afternoon to all. Today, our valuable speaker, Dr. Umashankar Subramaniam, sir, from Saudi Arabia. The topic is sustainable green energy charging infrastructure. The speaker introduction by Mrs. Devi Garani, madam.
A very good afternoon, one and all. I am honored to introduce this session speaker, Dr. Umashankar Subramaniam, sir. He is Associate Professor and Distinguished Researcher in Renewable Energy Lab, College of Engineering, Prince Sultan University, Riyadh, Saudi Arabia. He co-established the Renewable Energy Lab and directed towards the renewable energy and electric vehicle related research and projects as per the 2030 vision of Saudi Arabia and United Nations SDGs. He is also a part of 2030 International Steering Committee for Global Ranking and Global Distinguished Expert at Global Education Policy Network towards Sustainable Development Goals. Previously, he worked as Associate Professor and Head Department of Energy, VIT Vellore, and he has 15 plus years of teaching, research, and industrial R&D experience. He is a senior member in IEEE and member of PES and ISTE. He is an exco member of IEEE Saudi Arabia section from 2021 and organizing member for IEEE PELSIS 2021. He held positions as Vice Chair IEEE Madras section and Chair IEEE Student Activities from 2018 to 2020. He has published more than 250 plus research papers in national and international journals and conferences. He is an editor of IEEE Access, Helion Cell Press, Springer Nature, AEH, Elsewhere, and ITES Willy and other high impact journals. He received Danfoss Innovator Award Mentor during 2014-15 and in 2017-18 he received Research Award from VIT University. During 2013-18 also he received the INAE Summer Research Fellowship for the year 2014 and he guided 6 PhD scholars in collaboration with industry. He has also done collaborative industry research projects like Sustainable PSU Campus, Sustainable Microgrid Development at Saudi Arabia. So thank you for giving me this opportunity. Sir, thank you, sir. Now you can start the session, sir.
Thank you so much, ma'am. So it's my pleasure to present today's topic related to EV charging infrastructure and how we can charge the EV in a sustainable way. And this is also part of sustainable development goals. under SDG 7 or 9 or 13, something like that. So my today's topic is focusing on how and what is the recent trends in the battery and EV charging station infrastructure, and how we can do it using the green energy. So that's what the ultimate aim. So as of now, if you look at it, so in India, the EV revolution already started. So you know very well, and because of the policies as well as the global impact on clean energy and climate change. And not only that, I hope so you know very well now the current scenario, because this topic is suitable. Current scenario, you have Russia and Ukraine war, and because of that, the oil prices it's a keep on increasing. And another factor is post-COVID scenario. So now every country they started using the vehicles. So that's another reason. So why the oil prices is again keep on increasing. So we want to be energy independent. So that's the reason it's motivated towards the electric vehicle. But again, it requires investment. Okay, I hope so. So as of now, if you look at the first picture, so this is the one we are using at present. So we are using the fossil fuel like a petrol, diesel, and we are using the combustion IC engines, okay, for the vehicles. But now they introduce the electric cars in India. But what is really happening? The charging station, all the charging stations are not completely green. So, for example, if you take your home, if you buy one electric bike, okay, so how you can charge? By using your plug points. So how you get the electricity? It is from the conventional energy sources, okay, thermal power plant, nuclear power plant, and other conventional power plant. So, so if this is the case, please let me know. Am I audible?
Yes, sir, you are audible, sir.
Thank you. And if you take this case, so this is not our aim actually. So our aim is to have a clean and green energy. But what is really happening is, especially we are using the EV, but we are still using getting the electricity from the conventional energy. So it's not our aim. So what is our aim? So we need a green and clean energy as well as EV, so that it won't pollute, as well as it will be like green infrastructure. Okay, so if you look at the vehicle graph, this is the projection given from 2014 to 2030. So if you look at the scenario, so we are in 2022. So if you see the percentage, it's almost 20% is EV, battery EV. Okay, so if you look at 2025, it is like opposite. So 75% EV and 25% only IC engines. And after that, if you see, it is projected like every year there is a battery EV is a keep on growing. So the future is almost confirmed, like it's EV only. Okay. Then, so if you talk about EV, so the main things is how you operate your vehicle. So what is the source of current as well as the voltage? So this is the case. So where you can see, excuse me, there are two options. So one is battery, another one is fuel cell. Okay. Though battery is almost mature technology, it is a proven, and most of the factories, if you see, they started manufacturing the batteries, and we are already start using it. Okay, for most of our application, laptop or smartphone, or if you take a backup power supply, UPS. So everywhere, if you see, we are already using the battery. But regarding the car EV battery, so we need something, the characteristics are completely different. So we need to meet the expectation of the electric car. So that is a one thing. So most of the companies, they have started manufacturing this battery, because as of now, many companies, they are procuring from abroad only. Only few companies are there in India, so they are manufacturing this. So there is a huge opportunity in this domain. Second one, fuel cell. So battery, even though it is pure, but the waste, battery waste. So once you use the battery, so what you will do, just take your smartphone or laptop, okay? So the battery is gone means what you will do, just you throw it and you replace. So whatever you throw, it is becoming like e-waste, okay? So how you can handle this e-waste in the future is another big question. So that's the reason. So they have introduced alternative fuel. So what is alternative fuel? It's a fuel cell, hydrogen based fuel cell, and it is also clean and green. But the only issue is how we can generate the hydrogen energy. So that's the challenge here, because it requires also costs, okay, for generating the hydrogen. And not only that, you need to store the hydrogen. So that is another challenge. If you look at the global companies, so they already started, and if you see that they are planning to increase their capacity. So by 2024 or 2025, so many companies are doing this, okay? And when you compare the battery, so if you see it's a EV battery, it requires a complete capacity, okay, full capacity. Whereas a hybrid electric vehicle or long cycle hybrid electric vehicle or plug-in hybrid, if you look at it, the battery doesn't play a major role. Okay, only the fuel, your petrol and diesel will play a role. The battery might be useful whenever it is required. Okay, it may not be used. For example, if you take a Toyota RAV4, there is a car, or if you take Mahindra, or if you take Tata Nexon. So all these things you can find a lot of application of this battery-based vehicles. But it is as of now, you can see it's mostly it's a hybrid. But in the future, it will be completely battery-based vehicles on. Okay, so the use of the battery as of now, it's not that much. Okay, but if you start using pure electric vehicle or battery-based electric vehicle, then the battery capacity you need is much more. Okay. So now let us see one video, so which is demonstrating about the smart mobility by the Sun Mobility. So they have introduced in the Ashok Leyland electric vehicle or electric bus. So what they are doing is it's a smart battery swapping infrastructure. So how they can swap the battery within very quick time or very fast time. Okay. So this is what called a smart battery swapping infrastructure. So which they established in the Ashok Leyland factory in Chennai. So this is done by the Sun Mobility. So this is the one of the breakthrough in this, because if you see the electric buses and other things, so it should not take 1 hour to replace the battery. It should take only 3 minutes to 5 minutes to replace the battery. So then only you can easily commute from one place to another place. This is for the commercial and the public transportation sector. And what about the private and other transportation sector? So you have battery is there, and but if you are using a private vehicle, so you know very well, you can go to the battery swapping stations like petrol station, and there you can give your drained battery, and you can get the new battery, okay, completely charged battery. The next option is apart from the battery is you can charge. Okay, so instead of swapping the battery, so there is another solution, like you can charge your battery in the charging stations. It's something like a petrol station. So there are different opportunities for the charging. For example, slow charging or medium charging or fast charging. So these are the 3 different examples. It depends on the requirements or the location. For example, if you are in office or if you are in house, slow charging is enough. Okay, but where you need the fast charging, whenever you travel from long distance. For example, if you are traveling from Hyderabad to Vaishak, okay, so in that case, definitely you may need maybe 3 times or 2 times you need to charge, okay, depending on the kilometers. Roughly, if you take Indian scenario at present, all the Indian vehicles, battery-based vehicles, it is able to withstand around 250 kilometer to 400 kilometers. Okay, so minimum to maximum. So one-time charge. Okay. So then again, what you need to do, you need to park in some restaurant or charging station, and you need to charge. So there you need the fast charging. So this is very important. Another thing is in the plug-in charging. So one of the unique solution is given by ABB, because ABB is the pioneer in this particular domain. So they have set up even the laboratory also, charging stations also in the IIT Madras. If you have a time, you can come and visit. So it will be excellent platform for doing the research. And this has a lot of facilities like a bus or commercial or industrial or fast charging or commercial charging, so residential charging or apartment charging or any other supermarket. A different location they are installing the charging facility. So charging depends on this rating, power rating, and as well as the type of the connector. You have a different types like connectors, like a petrol charging stations, or like a top down, okay, top down or top up connectors. So it is ranging from 24 kilowatt to 600 kilowatt, like how fast you want to charge or how slow you want to charge. So it depends. So if you look at this, so EV charging roadmap, this is the case. So now if you see this, so it's something like GB fast charging standard, so which has been recently introduced by one of the company called GBT. And if you look at this, so it has been introduced by in the China. So it is charging around 900 kilowatts. So that means it takes maybe few seconds to charge the battery. So this is what the new technology. So let us see the video also about the new technology. So whereas the ABB has introduced this technology, in fact, this is the technology they are going to use for the Ashok Leyland as well. Whatever the buses they are manufacturing by the Ashok Leyland company in Chennai. So here, if you see that it is charging within 20 seconds. So let us see the video as well. If you see here, you can see that how long will it takes for charging the battery. This is one of the test bus in Europe. So in Europe, ABB has introduced this. You can see here, the connector quickly goes to top and it connects with the electricity. 1 second. Yeah. So if you see here, so how long will it takes? Okay, that is the matter. If you see here, the bus is moving, and the bus will get down in the stop. In the stop, you should have some facilities. You can see here the bus stop. So you should have the facility and it should connect. So 600 kilowatt means you just imagine 20 seconds. That's it. Just something like a passengers will get down and get in. Okay. So you need some facilities arrangements. So this is very important. So normal bus stops and this bus stop should be completely different. You need the power electronic facility or electric substation facility, etc. Okay. And almost in the bus, you should have the drive, electrical drive, as well as the converter system. And this is what the technology they are introducing in Chennai as well. That means in India as well. Okay. So then next is about the wireless transfer technology. So I hope so you know very well. So many of you, if you started using the mobile smartphone, so nowadays it is coming with even Samsung has introduced, and many other brands they have introduced wireless charging. So you can just place your mobile in the plate, okay, like plate. So it will charge automatically. So this is called capacitive charging or inductive charging. And if you look at this, the same technology they want to introduce to the electric vehicle. So how you can see here, the car will have the plate, and similarly the road or parking or charging station will have this plate. So if you exactly go and place your park your car exactly above this plate, so automatically it will start charging. So mostly it is a inductive charging, and capacitive charging also possible, but it requires very less gap. So this is one of the example. You can see the parking infrastructure. So you need to place this in the square box so that it can automatically start charging. This is called parking infrastructure. Whereas in abroad, that means foreign countries. So some of the countries like Norway, they want to introduce a separate lane for EV cars. What they are introducing is there is a charging infrastructure. You can see in the middle. So when you just drive above that charging infrastructure, so it will be charging dynamically when you are driving, when your car is moving. So this is called dynamic charging. Okay. So this is also they are planning. Maybe in the future, maybe you can see this facility as well once this is successful. India also, if you see, India introduced maybe in 2020 during the COVID time itself, the public first EV charging plaza as well as charging station. So you can see here it's like this. So the parking place itself be converted to charging station. So whenever you go to any plaza or mall or supermarket, so you will see this in the coming years. This is another one, this is another company. They are installing the charging stations on the highways, national highways. So wireless power transfer, it's the basics of your inductor and capacitor. So I hope so you will get the information, much more information if you study about this in your course. And wireless charging, if you consider, so there is a company called Vitricity. So this is the US-based company. So they introduced this technology. So this technology is very compact, and it's much more technology oriented, and it's a smart technology. So let us see how this smart charging is working, and how you can use this technology for your residential car parking. You can see here, this is your normal parking, parking place in your house. So you are moving your car, exactly you need to park your car above the plate. So it's like very simple, simple technology, simple infrastructure. Now you can see using the IoT. So it is monitoring how much is the charge. So how long it takes to charge, So it's a very simple facility. You no need to have a much more infrastructure. Another thing is that it is very much suitable for all the type of all the locations, not only your home, but anywhere, And the rating also, it's different, like depends on slow charging and fast charging. And it is very good, and it is having a more than 90% efficiency and safe also, Suppose if you have a kids, so it's a safe, You no need to worry about safety about this. And it is also suitable for all the type of vehicles, SUV, sedan, or a small vehicle or large vehicle. So any vehicle, it is much more suitable. So as of now, if you see, these are the three different opportunities of charging. Now, how you can make the infrastructure more green and clean. So for the charging facilities, as you know very well, as of now, you are using your electricity, from the electricity board. And if you look at this, so mostly the power is from the grid, But if you want to charge your EV, you need to modify your house infrastructure, or power infrastructure, or energy infrastructure. So how you can modify? You need to have some renewable based or solar or wind, small wind turbine in your home, and as well as some battery energy storage, and as well as technology, smart grid or IoT based technology to monitor the how much you generated, how much you used for charging, so like this. And not only that, in the event of like suppose if there is no sunlight, or if there is no wind, okay, it won't generate the power. So what will happen? So the electricity board, I hope so, it'll you supposed to use it as a backup. Okay. Similarly, for commercial buildings or offices or malls or supermarket or hypermarket, if you take anything, so it should have this kind of things. Okay. And similarly, car parking, if you see in future, you can make it double purpose. So you can install the solar in the car parking and the rooftop. And what you can do is even some places I have seen the solar itself is acting as a car parking. So there is nothing other materials they are using. And you can just store or you can charge your cars during the parking when you park the car. This is especially for the daytime. So what will happen for the nighttime? It is completely different. So maybe you can use battery energy storage, and you can use that stored energy for charging, okay, in case. But that is too costly now. Okay, maybe in the coming years, if the battery cost is reduced or battery energy storage is reduced, then you can start using this. As of now in India, if you look at, so these are the EV market. So auxiliary components and electric propulsion components, energy source, then body design. Okay, that means mechanical design. If you focus on energy and electric propulsion, so these are the categories like battery, battery charger, electronic controller, power converter, motor, transmission. Okay, that means a gear. So these are the focus now. So if you look, there's battery is a one important or futuristic area where you can get a lot of business. Why? Because it is expected that by 2025 or 2026, this is the projection for number of slow chargers, fast chargers, okay, DC charger as well as AC charger, okay, likewise. So if this is the case, maybe in the future, if you see, all the petrol and diesel bunks will be replaced by the charging station. And when you travel from one city to another city, you might be seeing a lot of restaurants, okay, in between, or like mini malls or something like that, or plaza. So it will be equipped with the charging station. So now you know very well the number of vehicles also more. So they need more and more charging stations in each location. As of now, if you see, the government has taken some initiative like a National Electric Mobility Mission Plan as well as FAME. Okay, and government is welcoming different companies, as well as they are much more interested in setting up of charging stations, especially using NTPC or BHEL, ESL or Tata Power or Ola. Ola also, they are into this business. Not only they are manufacturing the electric scooters, but also they are into this setting up of charging stations as well. And if you look at it, so many companies, even they have a tie-up with existing petrol bunks like BPCL or IOC, Indian Oil Corporation, or Bharat Petroleum, or something like that. So they have a tie-up, and they are gradually they will keep on replacing the existing petrol bunk with the charging stations. So if you look at this, so you have different segments, okay, two-wheelers, three-wheelers, private vehicle, and commercial and buses. So if this is the case, so what could be the futuristic aspect? So as of now, maybe some require personalized charging or private charging station, okay, in your home. But in the future, if you see, you may need both battery swapping stations as well as a personal, as well as public charging stations, okay. So these are the three aspects. So this is what the futuristic scenario. So in the futuristic scenario, you can see here, see the public charging stations going to dominate much more, okay. So if you see, almost all the vehicle, they will start using the public charging station rather than the private charging station as well as battery swapping stations, okay. Now, there are a lot of challenges also there, like e-rickshaw, there is no stand. If you look at Mahindra, they have manufacturing the e-rickshaws for the different commercial purposes. If you see Maharashtra or Delhi or Bangalore also, so they introduced this e-rickshaw, but as of now, there is no fixed stands like other diesel or diesel auto, okay. So e-rickshaw also requires some specific location as well as specific charging points. So that is another thing. substandard charging equipment. So the manufacturers are not experts as of now. So mostly they are importing from China, some other countries, and we are doing some assembly only. So we need much more expertise in this field. So we need more and more engineers in this particular domain. And electricity theft, it is a common in India, you know very well. So how we can avoid this theft so that in the future you may need more and more electric power. Okay, so there is a shortage of power also in case. So hope you know very well. So what's happening in Sri Lanka as of now? So Sri Lanka, so it is in the debt. So debt means they don't have money. So all the money, if you see that they are getting from other countries. So because of that, so there is a huge shortage of electricity, then price hike, etc., etc. So if you see that when you develop some plan, or if you want to replace the existing petrol and diesel vehicle with the e-vehicle and e-bikes, so you should take into account this also. Okay, otherwise there will be a huge economic issues will come into picture in the future. Now, if you look at this, till now we have seen, so what is different type of charging available and other things. I hope so. Any clarification you want from the audience? Is it fine?
Fine, sir.
Okay. So the next half of the topic is about how we can make it as a green EV charging. Okay. So if you see Schneider Electric CEO, he said in COP21, now we finished COP26. Okay. So almost 5 years over, but still if you see, the energy consumption is double now, and CO2 emission you need to reduce because all the countries they started working on climate change related issues and carbon emission. So we need to design all the equipment. So now you are seeing most of the electrical equipments. So for example, if you buy the refrigerator or air conditioning system or any other electrical equipment, so you see the star rating. Okay, so if it is 5-star means it's a good energy efficient. If it is 3-star or 2-star means it's okay. But if it is 1 or 2 means it's really pathetic, and it will consume more and more energy. Okay, so they need to focus on these things. So now if you look at it, so what about the existing electricity available? So we have a lot of demand in the electricity because almost all the cities, they are urbanization is taking place, more industrialization is taking place. If you look at your locations, so especially if you look at the Hyderabad or something, so it's more and more industrialization is taking place. Okay, so if this is the case, so we need to focus more on how we can manage the electricity, and at the same time how we can reduce the CO2 emission. And if you want to satisfy the first two, the third one, okay, so do we need any new electricity lines or transmission line, a substation, etc., etc.? So these are the key drivers. But if you see what is the plus points we have, technology is good. We have a very good IT infrastructure in India, active government and regulators, but we need active end users. That means we. So we as active end users, so we need to participate in this. Otherwise, it's a huge mess. Okay. For example, what is happening in Sri Lanka or what is happening in other countries. So related to the electricity, so the same will happen. Okay. So we should be very cautious, and we need to participate in this. So only if you satisfy both, then you can say the microgrid is possible. Now, if you look at our grid is like a one-way grid. Okay, for example, in some other remote location, you are generating the power. I hope so. If you take Andhra Pradesh, Ramagundam, all right. So there is a power generation, and it is transmitted to the long distances to Hyderabad, or if you take Vaishag or any other location, if you take or Vijayawada. So different locations, it requires long transmission lines. Okay, this is what at present is happening, and it is distributed by using the distribution station, and it is distributed to the consumers. Okay, like a residential consumer or commercial or industrial consumers. But what we need to do means what recently is happening. So there is a huge renewable energy power plants they are installing. The government is already doing it. And we also need distributed generation as well as local generation. Local means in your house or in your offices. Okay. Even this is also happening. Slowly it's happening now. Because the government has introduced a lot of plans and a lot of projects related to installing the renewable based power generation in the house as well as in the commercial sector. But what's really happened is because of the cost issues, and already whatever you are getting the electricity is fine because that is not costly. So that's the reason. So people, they don't have much interest on shifting to renewable energy. But now the cost is huge. Okay, so I hope so all of you understand. So the cost is keep on increasing. So I hope so the people mindset is also gradually changing now. Okay, they are moving towards green energy. So when you make the consumer more active, so what is the advantage? Not only the energy infrastructure will be good, but also as per our new EV policies, so you can have more and more EV cars, and you can charge your EV cars in your house as well as in the office buildings. Okay, this is what the ultimate aim. See, this is something like if you have money, you can spend. Okay, so if you want to spend without money, that is another mess. Okay, so it's the same like this. So if you want to buy electric vehicle, you should have the facilities to charge your vehicles, and it should not give burden to you, like you should not pay more and more electricity bill. Okay, and at the same time, if you don't have a facility in your office, or suppose if you don't have a facility when wherever you are going, for example, mall or supermarket, or if you're traveling from one place to another places, it's a huge mess. So what is very important is the infrastructure is very important. This is what we need to develop much more now. Okay, then only by using the technologies, okay, IoT or artificial intelligence, or if you take cyber physical systems, so all these technologies will act as a supporting things. Okay, and which will help for executing everything using a technology oriented, okay, or technology enabled. For example, the electricity bill now you can see in your smartphone, and you can get it as an email, or you can see in the website. Okay, and the same thing what will happen if you have more and more green energy as well as EV, you will have an app will come. Okay, already the app is available in Europe. The app will come. So using that app, what you can do is you can easily check what will be the uh, what is it, futuristic aspects also. Futuristic means how much you need to pay the bill. Suppose if you consume the electricity like last 2 days, so what will be the bill for the next 1 month or next 6 months or next 1 year? Okay, based on the data analytics. Okay, data what they are collecting. And similarly, if, in the future, if you see, there might be chances like if you are using all your equipments in the morning, for example 6 to 9, then the electricity bill will be more. After 9, the electricity bill will be less. So, or in the evening time, electricity bill again more. In the night time, electricity bill will be less. So like this, the option might come. So in that case, so what most of the people will jump is they will start using the electricity in the off peak time. Okay, not in the peak time. So what will happen? There will be a gradual share of electricity. Okay, so this is the case. Okay, and if you look at this, so this is possible only with the help of all the things. Okay, government and as an active end user consumer, then technology, then digital substations, energy producer, renewable energy, etc., etc. So all the technology should support, then only it's possible. Then you can say this microgrid as a smart grid. Okay, I hope so. Smart grid and smart cities is the concept the government is keep on announcing in the recent 10 years. I hope so in Andhra also, many cities, including the new capital of Andhra Pradesh, right? So new capital of Andhra Pradesh, I'm not sure what is the name. So there also, if you see, they are introducing this smart city plan. So what is meant by smart city? Not only this electricity or related to transportation, but also civil, mechanical work or public work department, everything they want to automate, including the traffic, etc. So now if you look at this, so this is the smart generation using integration of renewables and connecting to the grid. You can see wind power plants. We have a huge wind power plants. Almost 50 to 60% of the electricity, if you see, it is from the wind power plants only, okay, during the March to September. And now if you see, there is a lot of PV, like megawatt scale PV power plants installed by different companies and different industries. So now what they're encouraging is off-grid, like in your house. And similarly in the building integrated PVs, okay, and residential PV systems, okay, the backup power supply. So everything they are encouraging now in order to have a smart generation or green EV renewable based grid. So what is possible? Okay, so for example, if you look at this, so we don't want this one-way energy only grid. Then it is a huge, you know very well, most of you might have studied in the power system. So long distance transmission line means there will be considerable losses. 20% of losses is taking place. So whatever you generate, 20% lost in the when you are transmitting, okay? And whatever you receive, again, because of the less energy efficient systems or appliances, again, the energy loss will be there. So almost if you see, 30 to 40% is going in loss, okay, because of all these shortages or ineffective usage, okay. So what you can do is you can have more efficient homes with the EV charging and efficient offices, okay, with the EV charging infrastructure and other facilities, flexible distribution like a digital substation or smart generation like a renewable based. And also we can have a very good demand response, okay. By using this, you can make the smart grid happen. So once the smart grid happen, then you can have more and more EV you can easily manage in the coming years. So the next 5 to 10 years is very crucial. Otherwise, we may end up with the problems like Sri Lanka. So that's very crucial next 5 to 10 years. Because the EV vehicles are keep on increasing, but we don't have the facility to charge. Okay, so that's the another challenging infrastructure. Because of that, the electricity bill will rise. Okay, if you don't have enough infrastructure. The next one is when I was in India. So I worked on one particular project called there is a huge wind farm in southern part of India, especially in Tamil Nadu. So in the wind farm, if you look at it, so we had a old wind turbine. So we had enough land available between one wind turbine to another wind turbine. Okay, so there is a considerable distance will be there. So in that vacant land, so we installed the solar PV. Okay, and we used this wind as well as a solar as a hybrid. Why? Because you know very well, wind it will be very good. Excuse me, during the daytime as well as in the evening time. 1 second. Yes. So wind is good in the daytime as well as in the evening time or night time. Okay, so you know very well. Suppose if you are going to beach, because you are in Andhra, you might be knowing very well. I'm not sure about Vijayawada. So if you go to beach, you might be knowing, right? So you will get a very good wind. Okay, but you cannot install the wind turbine in the beach. That is also happening. Okay, so so wind is at some different time, and solar PV, if you take it, is only available in the daytime. So if you combine these two, you will get power continuously. So this is what the idea. And for that, in the future, so we decided like why not we have energy storage system, so that whenever there is no wind or no sunlight, you can still use the energy storage for a short time, okay, not for a long duration purposes, okay. And this will be connected to one 400 bar 11 kV substation, 250 kVA substation, where you have the transformer, and it is connected to 11 kV transmission line, so you can easily transmit the power. But it is advisable, like this is for a particular application, but it is advisable to use renewable at the local means in your place itself. Similarly, for any college or university, so this might be our plan. Normally, we suggest like a 1 kilowatt solar grid inverter, and you can install in your lab. And you can also have a battery-based system, the net metering, and you can connect the wind turbine also, 1 kilowatt wind turbine also. And this setup, you can fix it inside your lab. Like inside your lab means, for example, in your for the student demonstration purposes. Okay, these things and all you can install in the rooftop. And battery you can have. So all these things you can connect in your lab as a single big computer or a monitor, and you can have the SCADA or any other software, and you can use this for the later purpose. For example, you see here I have introduced ZigBee, GPRS, Wi-Fi, or TCP. All the protocol you can use. So you can just collect the data, as well as you can think of, for example, you can go to the lab and you can have small panel with artificial light, and you can design your own charge controller, inverter, or power supply, and you can test your converter or these things, okay, for your research purposes. The next thing is the future might be is based on the hydrogen. So there is no doubt in this. So that's the reason, if you see how they can generate the hydrogen as well as store the hydrogen by using the renewable energy sources. That is another important area. Okay. So hope my session was useful to everyone, and I hope you got some idea about what is really happening in the charging infrastructure or charging scenario in India, and how you can equip yourself as a student or a faculty or a researcher, so that the future you can get a lot of scope to work in this area. So I welcome for any kind of clarification or discussion if you have. So thank you so much for the wonderful opportunity.
Participants, please, if you have any doubts, you can post in the chat box, or you can unmute and you can ask.
If there is no questions, thank you so much for this wonderful opportunity. Thank you so much, Professor.
Yes, sir. Thank you very much, sir, for your valuable sessions regarding this renewable energy, sir. A wonderful opportunity, sir, to share your ideas, and we gained this vast knowledge, sir, regarding this. Thank you very much, sir.
So we will post the feedback link in chat box. Just wait for 2 minutes. All the participants are requested to wait for 2 minutes. We'll post the feedback link in chat box.